Welcome to CFP Wesco Cameroon, the School of Trades. You are here to build a foundation in professional data analysis. You might already know how to manipulate data in Excel. You might know every keyboard shortcut and formula. But if you take a column of customer phone numbers and ask the software to calculate the average, you will get a mathematically perfect answer that means absolutely nothing. The software will always do the math. As an analyst, your job is to know what kind of data you are looking at before you ever write a formula. Good traders naturally understand this. A vendor at a busy market knows exactly how to separate their textiles into distinct categories, and they know that you can count the daily revenue, but you cannot average the names of your clients. Statistics provides the formal architectural blueprint for the logic those traders use every day. We call this framework data types. This 3D grid represents a school register. Horizontal rows are observations, individual pupils. Vertical pillars are variables, like age and name. Variables fall into two families. First is quantitative data. If arithmetic makes sense, it's quantitative. Within this family, we have two subtypes. Think of a bakery at 5 a.m. You count the whole loaves of bread. That is discrete data. Or you can measure the exact weight of flour used, down to the decimal. That is continuous data. Whether you are counting discrete units or measuring continuous amounts, mathematical operations applied to quantitative data accurately reflect physical reality. The second major branch is qualitative data. These are characteristics, categories, and labels. You can count how many items fall into a category, but you cannot average them. The qualitative branch has nominal data, pure labels with no ranking, like cities existing side by side. By contrast, ordinal data has a natural ranking. A baccalaureate outranks a BEPC, but the mathematical distance between ranks cannot be measured. This brings us to a major vulnerability. Some qualitative variables disguise themselves as quantitative numbers. Take a look at this Douala taxi. The license plate CE901CP contains numbers, but it measures absolutely nothing. It functions exactly like a name. The same is true for an MTN phone number or a zip code. Blindly trusting digits without verifying their underlying category is a massive trap. Applying arithmetic to labels leads directly to false conclusions and bad business decisions. To avoid those traps, analysts use a strict interrogation protocol on every new dataset they receive. This flowchart maps out three sequential questions. First, can I do meaningful math on it? Second, is it counted or measured? Third, do the categories have a natural ranking? Following these yes or no pathways forces any variable to reveal its true type. Identifying the data type dictates the architectural limits of your analysis. Nominal labels safely route to pie charts and bar graphs, while continuous measurements open the door for scatter plots and trend lines. We can apply this to an MTN telecommunication survey. Regional labels sort directly into nominal, monthly spend drops into continuous, and 5-star customer satisfaction ratings land in the ordinal bin. Inside Excel, text defaults to the left, while quantities align to the right, showing exactly how the software perceives each variable. To maintain that structure, data validation locks ordinal categories into strict drop-down lists, ensuring typos never corrupt your results. Every formula, every chart, and every insight you generate depends entirely on the variables involved. Classifying your data is the mandatory first step before you execute a single calculation.